So if I'm asked to sketch these points in a three-dimensional plane, you are actually in luck because I'm terrible at sketching things in 3 dimensions, but I'm really good at getting all of my points. My guess is that most of you will end up being much better at this than I am, but I'm going to show you the things that get us all of our points as a quiz or test question. So the first thing, I'm going to draw in my axes. Now, there are a couple of different ways that we can orient the axes. I'm going to go with the way that our calculus textbook does, which means the x-axis we're kind of going to imagine sticking out from the board. The z-axis becomes our vertical, and the y-axis becomes our horizontal. If you take a physics class, oftentimes these will be changed around with your z-axis actually projecting out of the board. Going with this, if I need to sketch the point 0, 5, 2, that's actually telling me how many steps to take in each direction. So my coordinates are going to go x, y, z in that order. So if I wanted to show the point 0, 5, 2, I would take no steps out in the x direction, 5 steps to my right in the y direction, 1, 2, 3, 4, 5, and 2 steps up. 1, 2. So my point would be right here, and I would label that 0, 5, 2. That's going to give me full credit. I've shown that I went over 5 and up 2 by writing those little hash marks to get there. Another way that you could show this is by imagining that point as the corner of a box and then drawing in the rest of the box. So we have kind of a flat box in this case because we had no x component, but that's the corner where that sits. Let's look at another one. Let's take this 1, -1, 2 and plot that point. So I'm going to follow the same rules. That's going to be my steps in the x direction, y direction, z direction. So I'm going to take 1 step forward in the x direction, and then 1 step to the left in the y direction, and then 2 steps up. Now, this one's going to be a little bit better to show with the box. So this point up here would connect back to that z value of 2 and would kind of connect back here to have that back corner sitting where y equals -1, and then that front corner here at x equals 1, and we could draw in the box where that's the corner of a box. Again, you don't actually have to do that to get all your points. If you have to sketch a point in 3-dimensional space, what is expected of you is to show how you got there, meaning kind of mark off little tick marks for those where those steps are, and then to label the point 1, -1, 2. So let's say that I wanted to sketch x equals 4. Well, if I were sketching x equals 4 normally in the xy plane, I know this isn't usually how we would do it, but one way to think about this is to find x equals 4 and then say, because this was in the xy plane, I expected to see both x's and y's in the equation. But I don't have any y's in the equation, so I'm going to take that point I just found and extend it for every possible y value. And that is, in fact, what a graph of x equals 4 would look like. And the notation that we sometimes use is R2, meaning it's a plane with an x and a y coordinate. if I take that same graph and I come over here to 3 dimensions, or R3, I can take that same idea of, well, let's find x equals 4. So I'm going to go 1, 2, 3, 4. So I'm going to be standing at x equals 4. Because I was in 3 dimensions, I was expecting to see an x, a y, and a z show up in the equation. We're missing a y and a z. So I'm going to extend in the y direction and in the z direction. So x equals 4 is actually this plane that lies out at x equals 4. And technically that plane is extending forever because it's going to extend for all possible y and z values. So I think that should do it to answer 6A, which was another question that I was asked about. Skipping that one for a second, and we'll come back to it.